Hey everybody, this is Larry. This is June 12th. Year's almost half over every time I say the day of 2024. Here we'll do another problem that I haven't done before. I've been doing the highest number first in hopes to get something more interesting. Is this a new problem? The number seems high. Don't I guess so. I mean, I think like someone like Lenny knows, but I don't know. Anyway, hit the like button, subscribe button, join me on Discord. Let me know what you're thinking about this one. It's 3183. It's a medium problem, the number of ways to make the sum. You have an infinite number of coins of value 1, 2, and 6, only 2 coins value 4. What a weird problem. Okay, I take it. Given an integer n, return the number of ways to make the sum of n with the coins you have. Since the numbers may be mod, return a mod numbers. Okay. Mod. Okay. 223 is the same as 232, so the orders don't matter. So I mean, in general, this is usually a DP thing. 10 to the 5th is very DPable, and this is one of those things where in the worst case, I mean not in the worst case, what is it? You suppose I think this is a very Leetcode thing, which is like a little crappy, which is that you can pre-calculate or 10 to the 5th things and then just return the result, which is, I don't know. I feel like that's not in the spirit of how you should solve problems, but Leetcode sometimes makes it necessary, so I don't know. We'll see if we need to do it. If we do, we'll do it. I mean, it's not a big deal, but I'm also just putting it as a disclaimer because I'm like during a contest I wouldn't risk it. I would put it outside and like pre-calculate everything, but for now, for this problem, I won't do it raw, right? But this is actually pretty straightforward, right? It's straightforward DP, and if you want to write it top down, and it's pretty straightforward as well. So then you have count, and then maybe you have I don't know, how do I want to say it? Basically, you have, I like to do these in order, but it doesn't even matter, right? So you have maybe a force to show you how many fours are left. And then maybe an index. An index, I was trying to think about a more clever way of writing it. Maybe you could do a Boolean thing, but it doesn't really matter. And the index is maybe you can create your own index of answer is equal to 1, 2, and 6. And maybe you don't even need the 1 per se because you can, you can, whatchamacallit, right? You can, like you can, like if you do this in a different order, right? Let's say we have 1, 2, and 6, but let's say you have to do it in 6, 2, and 1. Then actually the 1 doesn't even matter because there's only one way to do n coins left, right? For example, so that could almost be your base case. So if that's your base case, then you can maybe even remove it, right? Yeah, because there's only one way to do it, and of course, another way to think about another thing to think about for this problem is that the force doesn't really factor into the index. So you actually technically you could break it down to two things, right? So you could do count. You can just do count on index, and then maybe like a count with 4 or something like this, and then you have like 4, something like this, and then you can say count 4, you start with 2, right? Mod, right? So then here you can say just return count the index of z. Oh, I messed up because of course you need the n, right? I messed that up. Sorry, friends. Yeah, 10 to the 5th, this should be okay, right? And 2 n. It's small n, but we'll make it big n. And then this is you can say yeah, count of index of 0 n plus count of 4 of 4's minus 1 n minus 4, something like this, right? I mean, of course, you have to do some if statements, so we'll actually write something like total is 0, 0. Total we added to count of the first index, and then we can maybe do something like if 4 is greater than 0, so you have 1 to do. N, oops, and n is greater than you go to 4, then you do this, right? Oops. And then you return total. And of course, here we can do total is 0, 0, right? Yeah, and then you can do, and then there are a couple ways you can do this. You can also do this with a for loop, which I don't recommend because it just adds too much. You can do a tick, no tick, right? Same idea. So you tick, no tick, and this is the same idea here as well, right? So you tick answer sub index. So that means that's total plus count of same index and minus answer. Oh, why did I call it answer? I meant like maybe denomination. So maybe den for denomination of index, and of course this is only if den of index is greater than equal to n, right? And here also, if index is equal to 2, we return 1 because there's one way to count, because it's just gonna be all ones after that, right? So then here we do right, and then no tick is just now we use the different coin, so we count of index plus 1 and right, and just return total. And of course you have to mod it. I think I forgot to mod it in the other one too. Yeah. And that's really it. I'm not going to go over dynamic programming today because this is already kind of involving. Or like the mechanics of the dynamic programming. I'm just going to do the lazy Python thing of just caching it. The memorization. I might actually rewrite this as bottoms up. Ooh, I did forget. Oh, this is wrong anyway. I got the signs wrong. This should be if n is greater than this. Yeah. And now we will submit. To be honest, there's a good chance that it will time out just because it's the sum of test cases, right? So we do the one test case, it is fast enough. But if they have like the same 100,000 input for, I don't know, 100 of them, it might time out. So I don't know if this is actually fast enough. That is just like mind reading on Leetcode's fat. And okay, fine, you even get a memory limit exceeded. And the reason why we get memory limit exceeded is because we don't, we move to cache, right? Leetcode is just silly. But yeah, but we have 100,000, so it's just that's just how it works. Okay, because if you want to, yeah, I mean, I kind of suspected this stuff, so I wouldn't have done this during the contest time, but I just feel like I wanted to show you this visualization and how I break it down, right? Because yeah, because I just want to show you how I break it down, and this is how I would break down the thing. So, okay, so how would I do it, right? Another way of doing it. Yeah, so let's try to do this DP bottoms up, right? I mean, yeah. So, yeah, there is an optimization that I want to use. That's why I'm kind of like hesitating if I should do it. But yeah, let's just say there's 0 times n, right? Or n plus 1, I think. And then one thing that we want to do is that there's one way to write 0. Yeah, and then you can really do these things in any order. So we can maybe do the fours first. I'm trying to think how clever I want to be, because definitely the order matters. But I think like you can actually you know, rewrite this as just 4 is equal to, because you can use one coin to get to 4, so it would give you the same thing, right? So it's just 0. yeah, so I mean, this is just, I mean, and obviously this is just 1, and then using 2 coin is just, this is equal to 1 as well. And then now you can do a lazy brute force on the denomination, right? So then now you have, say, for D in 6, 2, and maybe you want even 1 in this case. It doesn't really matter that much. And then now you can do DP for current in I think I'm actually doing this for max. That's why I didn't check bounds on this. But yeah, let's try to do this for max plus 1, and max is going to be equal to 10 to the 5th. Just add a couple of numbers there, as I usually do. For current in range from max counting to 0, I guess that's technically, it counts down to D minus 1. And then now dp of D adds to dp of D minus, current minus D. No, I this as well. This should be D going to max. That's why. And the reason why this looks very funky right now, let me double check. Yeah, okay. Is because we go up to max every time. But the thing that you can say is that we can actually just put this outside the code. So you could just, in a very crappy kind of way. So then you can only, you can get away with doing this only once. So yeah, pretty straightforward, really. Okay, it's actually not that straightforward, but basically, I think if I'm focusing on learning, this is the code that I would focus on learning. And then once you realize how to do this, then you can reduce this code to this code. And I realized that I did a really poor job of kind of converting from here to here. But I would also say the reason why I am very familiar with this and I was able to skip a few steps, which my apologies for not really talking about this one, is that this is a classic coin change problem. It's a variation on a pseudo polynomial problem, pseudo polynomial dynamic programming problems. Some of which is, as you know, coin change, and then the other one that is well known is knapsack, right? One fun fact for you, for the long-time viewers, is that I wrote the first version of the Wikipedia article for coin change. So so you can say that I am very familiar with it. I don't think it's there anymore. I don't, but yeah, that used to be true. Because not directly, because I didn't use Wikipedia, but I wasn't an editor on Wikipedia, but I used to run a Wikipedia, like a wiki, not a Wikipedia. I used to run a wiki that had, and I wrote very much details on coin change. Of course, that had an open licensing, so someone took it and put it in Wikipedia. So for a long time, the coin change, and by a long time, I mean like a couple of years, so maybe, and that was even a long time ago, so that was not true for a long time. But yeah, coin change is one of those things. Yeah, there are a lot of subtle things here that I didn't really go over, but definitely, it is something that is very fundamental. Even though this particular hack is Leetcode specific, so I don't know how I feel about it, but it is what it is. That's all I have for this one. Let me know what you think. Let me know in the questions, because I think maybe I need to kind of figure out how or what kind of things to go over with these type of problems. But that's all I have for this one. Let me know what you think. Thanks for watching. Stay good, stay healthy, do good mental health. I'll see y'all later and take care. Bye bye.